Okay, in this video we are doing problem set 99 from Calc AB. The problems and a link to the playlist are in the description. Let's take a look. Number one, we want to evaluate the integral of 5x minus 2 over the quantity 5x squared minus 4x plus 3 all to the 8th dx. This to me looks like a kind of classic u-substitution problem where you want to make u the thing in parentheses, preferably to the highest power, or the thing in the denominator. There's a lot of options here for why we're going to choose u is equal to 5x squared minus 4x plus 3. If that's the case, we got to figure out du so that we can sub in for dx, which is like the most commonly forgotten part. So du is going to be the quantity 10x minus 4 dx. Now, when you look at the original problem, you don't have 10x minus 4, you have 5x minus 2, but 10x minus 4 is a multiple of 5x minus 2. If I divide both sides of my du, my differential, by 2, I'm going to get what I need. So I'm going to do 1/2 du is equal to 5x minus 2 and then dx. So we can make direct substitutions. So we have to sub in for 5x minus 2 dx. That's going to be 1/2 du. I'm going to pull the 1/2 out. 1/2 integral du over 5x squared minus 4x plus 3 is u. So u to the 8th. I think it's easier to do this. So usually I do this in my head, but usually I'll just rewrite this as u to the negative 8th du, so I can do plus 1 times the reciprocal. So it's going to be 1/2, and then negative 1/7 u to the negative 7th plus c. So that's going to give me negative 1/14 u to the negative 7th plus c. And then u is equal to 5x squared minus 4x plus 3. And so we finally get negative 1/14 quantity 5x squared minus 4x plus 3 to the negative 7th, and then plus c. So let's look at the next one. Use the graph of f to answer the questions. The graph has a horizontal tangent at x equals 4, so I kind of hand draw these, and it's hard to do that, so I'm just telling you straight out that's actually a horizontal tangent at x equals 4. For part A, if g of x is x squared over the quantity f of x minus 1, we're going to find g prime of 1. So we need to find g prime of x. This is a quotient, so we'll use the quotient rule. So here goes. G prime of x. You're going to have bottom, which is f of x minus 1. Put that in parentheses. Derivative of the top is 2x minus top, which is x squared. Derivative of the bottom is f prime of x. All over the bottom, which is f of x minus 1, squared. All right, so now we're supposed to plug 1 into that because we have to find g prime of 1. So, everything just becomes a 1. So we have f of 1 minus 1 times 2 minus, it's really 1 times f prime of 1, and then f of 1 minus 1 quantity squared. We got to work out these values, though. So I'm going to go to the graph. I'm interested in 1, right? So I need to write the equation of this line. I think it's going to be y minus 1 equals, you're going down 4 over 3, right? Like that's the slope of that line. So y minus 1 equals negative 4/3 quantity x plus 1. I use the ordered pair negative 1, 1 as like the anchor point for my point slope form there. So now the next thing that we're going to do is use this to figure out f of 1. So I'm going to plug 1 in, and it'll be 1 minus 4/3 times 2, which is 3/3 minus 8/3, so negative 5/3. So that's f of 1. That's a value we'll plug in. And then also from the tangent line, you know f prime. So f prime of 1 is the slope of this tangent line, which is just negative 4/3. Sorry, I'm saying tangent line, but it's literally just a line in this case. It's not actually tangent to anything. I mean, it's probably tangent to something, but not in the context of this. All right, so f of 1 is going to be negative 5/3. F prime of 1 is going to be negative 4/3. We're plugging in. So we're going to get negative 5/3 minus 1, and then times 2, minus negative 4/3, all over quantity negative 5/3 minus 1 squared. You can do this, it's like basically arithmetic at this point. Negative 16/3 plus 4/3 all over 64/9. And then when we simplify that, we end up getting negative 9 over 16. Pretty good problem. Let's look at the next part. B, use one-sided limits to show that f prime of 2 does not exist. So based on the graph, you can see that f prime of 2 does not exist. There's just like a sharp turn there or a corner there. Either of those would be fine if it didn't say use one-sided limits. For one-sided limits, I'm going to use the version where it's like the limit as x approaches a, f of x minus f of a over x minus a. So in particular, I'm going to do the limit as x approaches 2 from the left of f of x minus f of a over x minus a. So that's the slope of the curve when you're to the left of 2. Looking at the graph, we already know the slope of the curve to the left of 2 is negative 4/3, so that's definitely negative 4/3. Now we're going to find the limit as x approaches 2 from the right, or try to. We kind of can't, but we definitely know something about it. So limit as x approaches 2 from the right, f of x minus f of 2 over x minus 2. If you look at the graph immediately to the right of 2, you can see that the graph itself is increasing to the right of 2, right, between 2 and 4. So since the graph is increasing, that means that the derivative there is positive. So this is definitely greater than 0, right? The slope of the curve to the right of, immediately to the right of 2 is greater than 0. There's no way that a negative value and a positive value are equal. So at this point, we can say that the limit doesn't exist. And because this limit doesn't exist, we now know that the derivative doesn't exist because that's the definition of the derivative. So we know that that limit, which is f prime of 2, does not exist. And we prove that f prime of 2 doesn't exist. The function is not differentiable there. That's a pretty good question. You want to get used to that kind of thing. All right, for part C, if h prime of x is f of x, so h prime is f of x, does the line tangent to h of x at 5 over or underestimate the true value? So this is going to come down to basically concavity, right? When you're talking about tangent lines and over underestimates, you're talking concavity. If you're talking concavity, you want to talk about the second derivative being positive or negative. Or if you have the first derivative, you want the first derivative to be increasing or decreasing. So in this case, we have the first derivative because h prime is f of x. Between 4 and 6, you can see that f of x is decreasing, which means h prime is decreasing. And if h prime is decreasing, h is concave down. So we're going to start with that as part of our argument. So between 4 and 6, h prime is decreasing. Decreasing means that h of x is concave down. And then if h of x is concave down, we know that the tangent line is above the curve, so the tangent line will give an overestimate. That's another really good question. These are good practice problems, if I do say so myself after I wrote them. All right, number 3. The position at time t of a particle is moving at the position at time t of a particle, I don't know. As soon as I said they were good problems, I just messed this one up. Let's say the position at time t of a particle moving along the x-axis is x of t equals 2t cubed minus 5t squared minus 4t plus 6. Is the velocity of the particle increasing or decreasing at t equals 1? This is actually a pretty straightforward question, but it's like one level below what maybe you're thinking. So first, I'm going to find velocity. Velocity is the derivative of position. We have to say that if we want all the points. And then there's just power rule. So 6t squared minus 10t minus 4. Now I want to know if the velocity is increasing or decreasing, which means I need to know if v prime is positive or negative. V prime is the acceleration, but I don't really need that for this. So I'm just going to say v prime and power rule this thing, get 12t minus 10. And then I need to know what v prime of 1 is. So v prime of 1 is going to be 12 minus 10, which is 2. 2 is greater than 0. So we can say since v prime of 1 is greater than 0, v of t is increasing at t equals 1. So like I didn't actually figure out if the speed was increasing or decreasing because it's not the question. I would need to know velocity and acceleration for that, but it wasn't the question. This was strictly, is the velocity increasing? And because the derivative of velocity at that point is positive, the velocity is increasing. All right, that's the whole problem set. I hope this was helpful and good luck.